flow into gratitude. Because for the next few moments, you are about to stand before a mathematical creation that was never meant to be easy. A problem so vast that every equation feels like a locked door, every symbol hides another universe, and every answer creates 10 new questions. Be grateful that your mind is about to enter territory where curiosity becomes courage, and where mathematics stops being a subject and becomes an adventure. Imagine a single particle resting quietly at the point 1, 1. It knows nothing. It has no destination. Yet the moment the journey begins, every branch of mathematics awakens to shape its fate. The first force to emerge is number theory. The particle is seized by the rhythm of prime numbers and Fibonacci numbers. Every new prime twists its direction. Every Fibonacci number bends reality a little further. Together, they generate an angle so precise that even the slightest error at the beginning echoes forever through everything that follows. But the rotation is only the invitation. Suddenly, calculus takes control. The particle is released into a living differential field where every instant changes the next. The equations breathe. Growth competes against decay. Sine waves collide with cosine waves. Every derivative influences another derivative. Every infinitesimal movement rewrites the future. Integration silently records every step the particle has ever taken, preserving the entire history of its motion inside a single accumulated quantity. Just when the trajectory begins to make sense, probability arrives. A random event decides the particle's destiny, not because mathematics has become uncertain, but because uncertainty itself has become part of the mathematics. A beta distribution is summoned. One invisible outcome reflects the particle across one universe. Another outcome throws it into a completely different one. Two futures exist. Only one survives. Now recursion begins to tighten its grip. The entire path traveled is compressed into a single integral. That integral becomes another quantity. That quantity becomes the input for the next transformation. Every previous decision now influences every future decision. Nothing can be forgotten. Then progression enters. An infinite harmonic product stretches and compresses the particle's distance from the origin. Tiny factors, each almost insignificant, accumulate until they reshape the journey itself. One multiplication changes almost nothing. Thousands of them redefine everything. Before the particle can recover, number theory returns. Euler's totient function measures hidden relationships between numbers. The divisor function counts every possible factor. The divisor sum function contributes its own ancient arithmetic. These aren't decorations. They physically translate the particle through mathematical space. Arithmetic itself becomes motion. Geometry has been watching in silence. 3 points are chosen: the origin, the previous position, and the current position. A triangle is born. Now the triangle must reveal its secret. If its circumradius exceeds a logarithmic boundary, the particle is forced toward the calm balance of the centroid. If not, it is thrown toward the mysterious orthocenter, a point where altitudes collide in perfect geometric tension. Every triangle becomes a judgment. Every judgment changes the future. Then linear algebra awakens. A matrix appears. Not an ordinary matrix, but one whose entries are built from primes and Fibonacci numbers themselves. The matrix is raised to a power determined by the divisor count of the current integer. Transformation after transformation compounds. Coordinates no longer simply move. They evolve. You think you've understood the pattern. You haven't. Now comes the fractal test. The decimal expansion of the particle's coordinates is inspected digit by digit. If 3 identical digits appear in succession, the universe softens. Coordinates collapse through square roots, compressing complexity. If they do not, the coordinates are cubed. One tiny pattern hidden inside the decimal expansion determines whether reality contracts or explodes. Finally, the infinite series begins. An alternating summation built from every prime encountered throughout the journey quietly accumulates in the background. Each term seems harmless. Together they become exponential scaling itself. The entire history of the particle is multiplied by the invisible weight of an infinite analytical structure. And only after number theory, probability, differential equations, integration, infinite products, recursion, geometry, linear algebra, fractal dynamics, asymptotic analysis, and infinite series have each taken their turn. Only then do you ask the real questions. Does the infinite sum of every transformed position actually converge? If it converges, can its exact value ever be known? Does the particle remain forever bounded, or will it eventually escape to infinity? Will geometry choose the orthocenter infinitely many times? Does the entire random process settle into a stable probability distribution? Does the path possess a Hausdorff dimension that truly exists? What is the asymptotic growth rate of its distance from the origin? Does the logarithm of that distance, normalized by the square root of time, approach a meaningful limit? Are the eventual destinations finite, countably infinite, or an uncountable mathematical landscape? And perhaps the most unsettling question of all, if you change nothing except the very first point, from 1, 1 to 1 square root 2, does the entire universe of this problem transform into a completely different mathematical reality? This is no longer a question. It is a labyrinth. A machine may compute it. A mathematician may spend years studying it. But every step through it reveals the same truth. The deeper mathematics becomes, the less it feels like calculation, and the more it feels like exploring the architecture of reality itself.